Alright, in today's video, we're going to look at another way to solve systems of equations, and this time it's going to be called a method using elimination. So today's title will be Solve Systems Using Elimination. So make sure you put today's date in the top corner of your notes. So let's just do a quick definition of what elimination is. So to eliminate something, that just means to remove it. Remove or get rid of. So in the context of our problems, we're going to be eliminating one of the variables because we can use that to help us when we're doing our elimination problems to solve. So let's say I gave you this example. We have a system of equations. So we have our bracket, and then we have the two equations. 3x plus 2y equals 8. 2x minus 2y equals 12. So we wouldn't do graphing with this problem because these equations aren't set up to graph. And we also wouldn't do substitution because we don't have one of the variables solved for. So here we have elimination because what you see are the x's lined up on top of each other, then an operation in between, and then the y's lined up on top of each other. So this is called standard form. So both equations are in standard form. So if I'm going to eliminate, I'm going to get rid of one of the variables. So if you take a look, the y values are the opposite sign but the same number. So if I add those two things together, I just take the two equations and add them together, watch what happens to my y values. 3x plus 2x gives me 5x. But now, when I add these two, they're going to cancel out. So I get 5x equals 20, because I have to add both sides. And now I can solve that equation for x. And dividing by 5 on both sides, I get x equals 4. Remember, with these elimination or substitution and system of equation problems, you have to plug in your values to find the other coordinate. So we have x equals 4, we need to find the y value. So I'm going to take the top equation, and I'm going to substitute in 4 for x and see what I can get out for y. So 3 times 4 is 12. To solve for y, I can subtract 12 on both sides and get 2y equals negative 4. And then divide both sides by 2, y equals negative 2. So the solution here is 4, comma, negative 2. So when x is 4 and y is negative 2, that satisfies both equations. So we'll number this one number 1. And we'll try another problem. Okay, so let's look at another example. This time our system looks like the following. We have x plus y equals 6, and negative x plus y equals 8. So again, we're set up for elimination because the x's and the y's are lined up next to each other and there's an operation set up in between them. So if I just add these two together, let's take a look at what happens. The x's look like they're going to cancel out because they're the opposite signs of each other. So I have positive 1x and negative 1x. When I add those together, they cancel. So I get 2y is equal to 14. From here, I can just divide to find my y value, and y equals 7. So now remember, because we're doing a system, we need two solutions, or two coordinates to our solution. So I'm going to use the first equation. I'm just going to plug in what I got for my y value. So y was 7. So I have x plus 7 equals 6. And now I can solve for x and get x equal to negative 1. So my solution here is negative 1, comma 7. So when your systems are set up where one variable crosses out with the other one, all you have to do is add the two equations together and you'll be able to eliminate one of the variables and solve for the other one. Let's take a look at an example where we might have to do some manipulation to make this process work for us. So we'll try the next problem. I've got 3x plus 3y equals 18, and negative x plus 3y equals 10. All right, so it's set up for elimination again because I have my variables being added together or subtracted together, and they're lined up on top of each other. It's different than when we had substitution and graphing. The problem with this one, though, now is which variable would be eliminated. So the common answer might be that y should be eliminated right away, but before I can do that, they need to be the opposite sign. So right now, if I try to add these together, 3 plus 3 would give me 6, so I can't do that. So for this problem, I have to change the signs in one of my equations in order to eliminate. And to do that, I have to multiply everything in the equation by a negative. So I'm going to do that with the bottom equation. You could choose either equation, but I'm going to go with the bottom one. I'm going to multiply everything on the bottom by negative 1. So multiplying everything by negative 1, that's going to change this equation to be positive x minus 3y equal to negative 10. I just changed the sign for each term in that equation. Now I'm going to rewrite my original equation underneath it. And so here's my system again. I just rewrote it by changing that one equation by multiplying everything by negative 1. So now to simplify this, now I can just combine these and add. So I have 1x plus 3x is 4x. Negative 3y and positive 3y, that cancels out. And negative 10 plus 18 is 8. So now I can divide by 4 on both sides and get x equal to 2. So with this problem, I had to multiply the second equation by negative 1 in order to set it up so I could eliminate it. I'm going to start with my original first equation there and the second one. And now that I know what x is, I can plug it in and solve for y. So to get y by itself, I have to subtract 2 from both sides and then divide by negative 3. So y is equal to 4. So my solution for this problem is 2, 4. And that's using elimination to solve a system of equations.